Filler rod. Direction of weld. Gtaw head. Power shielding gas. Contact tube. Tungsten electrode. Non-consumable. Weld bead. Shielding gas. Copper shop. Optional. Electrical arc. High frequency unit and power source. Solenoid valve. Grounded workpiece. Electrode. Cooling. Weld pull. Protecting gas. Arc. In TIG welding, arc initiation is done by high frequency start without touching the workpiece. The torch is lowered toward the workpiece such that tungsten electrode is held a little above the workpiece. There will be a little gap between the electrode tip and the workpiece. Then the power source along with the high frequency unit is switched on. The shielding gas starts flowing through the nozzle and the arc starts between the electrode tip and the workpiece. Shielding gas. Welding power source. Workpieces. Arc. Tungsten electrode. Shielding gas. Electrode holder. Gas supply. Shielding gas is directed by the torch to the arc and to the weld pool to protect the electrode in the molten weld metal from atmospheric contamination. Since there is no flux used in TIG welding, the inert gas shielding protects the weld pool from oxidation. Equipment and accessories. Pedal switch. Ceramic nozzle. Arc. Argon shielding. Work. Tungsten rod. Argon gas in. Cooling water in. Welding cable and cooling water in tube. Cooling water out. High frequency connection. Power source. Solenoid valve. Argon cylinder. HF unit and water cooling system. Flow meter. Regulator. There are various types of power source for Gtaw: inverter DC, thruster, DC, motor generator, DC, rectifier, DC, transformer, AC. For aluminum welding only, power source of Gtaw provides electric energy for arc and heat generation. It has drooping characteristic, current range 40 to 400 arc voltage 18V to 26V. HF unit provides high voltage electric energy with very high frequency of 10,000 cycles second. It initiates low energy arc and ionize air gap. Electrically charges air gap the welding current to jump across the tungsten tip and workpiece to form an arc. HF gets cut off once welding arc struck. When pedal switch is pressed, solenoid valve opens, argon gas flows and high frequency starts jumping from tungsten rod. Welding current flows generating an arc across tungsten rod and workpiece. High frequency gets cut off from the system and welding continues. When pedal switch is released, current gets cut off, arc extinguishes, gas flow remains for few more seconds before it stops. Water cooling system, engine, wet exhaust, heat exchanger, expansion tank, thermostat and housing, circulating pump, pulleys, raw water pump, sea water strainer, scoop strainer, through-hull fitting, C-value. Water cooling system provides cooling water to welding torch. Cools tungsten rod, torch handle and welding cable. Cooling water returns through flexible tube which carries welding cable within. Gtaw torch. Earthing cable, tungsten rod, ceramic cup, cap with collet for holding tungsten, torch handle, cooling water outlet, argon gas inlet, cooling water inlet tube with cable, argon shielding gas, arc, base metal. Gtaw welding torch holds the tungsten electrode. The shielding gas is also supplied through the torch to the arc zone. Touches are rated in accordance with the maximum welding current that can be used without overheating. Different sizes of electrodes and different types and sizes of nozzles can normally be used in the same torch. The heat generated in the torch during welding is removed either by gas cooling or water cooling. Accordingly, the torches are called as gas-cooled torch or water-cooled torch. Gas-cooled torches provide cooling by the flow of the shielding gas through the torch. Gas-cooled torches are used for maximum welding current of about 200 amperes. In water-cooled torches, cooling water enters through the inlet hose, circulates through the torch, and exits through an outlet hose.